Ready? Welcome to Let's Build a Synthetic FHIR Dataset. I'm Jason Walonski from the MITRE Corporation. There's a bit.ly here. It's going to be on every slide. It's 2IANQK and then a lowercase q. And since it's a Let's Build, I'm hoping that if you have your laptop open, you'll pause momentarily on your email and everything else you're doing and actually follow along. I'm going to try a little experiment. Maybe call it a little performance art, and it will fail if people don't participate. So I'm ready to fail, but I hope people will actually follow along. So if you can, open up the bit.ly. We'll have some step-by-step instructions on what we're going to do today. Although one of the steps I'm actually going to skip because it wouldn't be possible to do within the 40 minutes we have. So let's build a synthetic FHIR dataset. So this is what we're going to do today. If you're going to follow along, follow the bit.ly and start cloning the database, or start cloning the repo now, because it's going to take you a few minutes. But what we're going to do is we're going to walk through the using, configuring, and customizing of Synthea, which is an open source synthetic patient generator, and we're going to create a synthetic patient cohort. And then what I'm going to try to have us do is everyone who's actually participating to load all that data into one place. And at the end of DevDays, we'll have a set of data that more than one person has generated. We're going to kind of try to distribute the generation of some data. And this link here to GitHub, this wiki link, is actually, that's where your bit.ly will send you if you follow it along. So yesterday, I think it was yesterday, time's a blur when you're jet lagged, Peter Lee from Microsoft in his keynote, which was I thought was excellent, he was talking about data liquidity, and he had this slide, water, water everywhere, nor any drop to drink. And my response is, I can't give you any real data, but I can give you a whole lot of synthetic data. So if you're thirsty, then you came to the right talk. So some of the prerequisites for this, you need Git, because you need to clone the repo. You need JDK 8, 11, or 12. I don't really care which one. I use 8, but you can use any of them but 10, because 10's weird, so don't use 10. In fact, if you have 10 on your machine, you should probably remove it. And then if you want the optional step at the end, you need to get the Microsoft Azure AZ copy utility. You can download it. There's Windows, there's Mac, there's Linux support. It's basically a precompiled executable. It takes like a minute to download. And the idea is Microsoft as hosts have sort of graciously given us some free storage space where we can put our data sets when we generate them. So you can use this utility to store them there. So the first thing, if you haven't started and you want to participate, you should start cloning this repository now. And the instructions are also in the bit.ly, which is still there if you want to just copy and paste. And basically, you want to clone the repo, and then you want to run some tests. This step is going to take 5 to 10 minutes, so you should probably start if you want to. And let's try that. So I already have it cloned. Here's my path. If I do git status, the only thing that's in here is I actually downloaded this AZ copy utility already. And if I run a Gradle clean test, it's going to start cleaning up my build folders, and we'll start testing. And this is going to take a couple minutes. There's several hundred tests it's going to run. And so I'm going to let this run, and we'll come back later. So what is Synthea? It's a synthetic patient simulation. As I mentioned, it's open source. It simulates the complete medical history of patients from birth till death. By default, it only writes out the last 10 years of their history, but you can change it to output a whole lifetime of health data. The goal is to output really high quality synthetic records that are realistic but not real, that you can use for all your health IT sort of needs. So that could be interoperability testing. It could be hacking with FHIR. It could be demoing applications where a group of people where you need really good synthetic data because you don't want to show them any PHI or PII. You could also use it for having a significantly large data set where you want to do different statistical analyses, or you want to basically create a pipeline for analytics or machine learning. Obviously, the data itself isn't going to give you really good predictive value, but it will help you set up the pipeline. So if you have a request for going to an IRB board for real data, that could take 6 to 9 months maybe, and so you've got your development process going. And then the best part is it's all freely available. The code's freely available. It's open source. And then the data itself is free from basically any kind of restrictions whatsoever. So that's great. When we started this project, we started with what I call the 2 top 10s. So we wanted to have coverage for the top 10 reasons patients would go to visit their primary care physician. So these are like routine infant-child health checks, hypertension, pregnancy, ear infections, asthma, those kind of things. Just the reason people go every day to see a doctor. And then the top 10 years of life lost. So these are, in the United States, are the chronic conditions that tend to cause disability or to cause death. So heart disease, lung cancer, Alzheimer's, things like that. So that was our starting goal, so that you'd have a data set that provided some breadth as well as depth for the common type of stuff you would see in an EHR or in a medical record. And subsequently, we're up to, I think, 90 modules or something at this point, and we're slowly adding more. So over time, this will get better and better. And it's open source. There's people who have contributed modules, and if there's a disease that you need modeled for your use case or that you happen to be passionate about, we love to take pull requests. And one of the things I'm going to show you now, is here's the, if you followed the bit.ly, this is the instructions, is we have this thing called the module builder. And the module builder lets you see these disease models. And essentially, for those of us who have a computer science background, it's basically a glorified state machine. There's a lot of documentation here about where all this information came from, all the references. This one is for congestive heart failure. And then there's different notes about it. And you can see the state machine, I'm zoomed way out, is pretty big and complicated. If I start to zoom in, one of the things that I can see is that there's different types of states. This is an initial state, so that makes sense. You want to start at an initial state. There's an age guard, which is going to let me basically wait until people are of a certain age. You can see as I clicked on these states, there's different types of fields that you can change. One thing you could do is I could say, well, I'm going to wait until people are 30, so I want to decrease that. Or I could just say that I'm going to change the rate of the onset of congestive heart failure, so you can edit these, and I don't know, maybe I'll double it to 6 in 1,000. And what happens is all of this is actually JSON that happens to be rendered. And so the JSON drives the way Synthea works. And you can see things are in here. You've got link codes in here that are telling what needs to be recorded. And I've made a change. You can download these changes. Here's the JSON. If I hit download, it's saving it to my machine. And then what I could do is I could go and copy that, and I could put it into the source main resources modules folder. Oops. Where did it say? Oh. This is what happens when you demo live. And if I do a git status, I can say I modified the congestive heart failure file. If I do a diff, I can see that I've changed now some of the distributions. You saw me change the 50 to the 20. You saw me change, I significantly raised that. That's going to cause a lot of heart attacks. So, that was an error. But what you can do is you can use the module builder to make changes to the different disease models if you want. The whole point is you can change different prevalence rates. You can change how they behave. And if you want to, you can do that now. You can mess around with the module. You can copy it to that modules folder. And then you can actually change the way that Synthea behaves and the different type of diseases and cohorts that they create. I'm going to actually undo that change because a lot of people will die otherwise. And let me go back to the presentation. OK, so just to recap, the disease models, they're state machines. There's different types of states. I'm not going to get into it, but the wiki has a ton of documentation about them. And it's just JSON underneath. This might be a little weird to read, but it's 2 columns of JSON. Those yellow highlights are actually the names of the states that you might have saw. This one is no ear infection, gets ear infection. There's an ear infection encounter. And then you can see they match up. Here's the initial state, the no infection, gets ear infection. And the other thing I have highlighted here is this blue. And this is the type of state. And some of these, you'll notice, actually match up or align not exactly, but fairly well with FHIR resources. And so this is the type of thing where a condition onset, I wonder what that does. It creates a FHIR condition. And there's actually a SNOMED code in here for odious media, which is an earache. There's an encounter, so that's going to create an encounter resource. The medication order, that's what it used to be called back in the earlier versions of FHIR. So it creates a medication request. This is an antibiotic. And another medication request for acetaminophen for pain and fever, I guess. And so you can modify all these, and there's tons of documentation about how to do that, and you can use the tool. So hopefully, what we're going to do now is we're going to run Synthea, and we're going to, our tests, I hope, are done by now. OK, well, they were, because I was doing stuff. So the tests were done. So to run Synthea, you just type run Synthea. And there's a number of parameters. I could just hit enter, and it will run a single patient. You can also provide a seed. So this way, you can try to generate the same set of patients repeatedly over and over again in case you want to, for reproducibility of tests or something that you're trying to do. I like to use seed 0, but you can use any number you want. So I'm going to run. What it's going to do is it's going to load all the modules. You can see it's loading up all the modules dynamically. And then it told me it generated a population of 1. It used a seed of 0. It ran from Massachusetts. That's the default location. Synthea in the demographics has almost every named location in the United States. But the default is just to run someone in the state of Massachusetts. There's an age range. And it happened to generate someone named Bridget Jaskolski, a 16-year-old girl in Chelsea, Massachusetts. So, OK, let's go look at that file. So what do we got here? We've got a bundle. It's a transaction bundle. It has an entry. There's a patient. Let's see. The patient has some extensions. This is the race, US core race extension. What else does ethnicity, mother's maiden name, birth sex. These are US core birthplace. She was born in Brockton. She has disability adjusted and quality adjusted life years. That's interesting. Let's see. She's got an MRN number. She's got a social security number, driver's license, all the other information you might expect. She's got an address that's geolocated somewhere in Chelsea. Let's see what other types of things are in here. So let's see if she has any conditions. Oh, she's got a condition. This one is resolved. She had viral sinusitis. Let's see what else we've got. Oops, didn't want to do that. Let's see, she has, well, we know she's going to have encounters. So there's an encounter. Let's see. That's not, let's see if there's any medication requests. Medication request. So here's a medication request for acetaminophen. Oops. Here's another one for acetaminophen. This one's acetaminophen with oxycodone, so I wonder what that was for. Oops. This one, abuse deterrent oxycodone. So maybe she got some painkillers and she kept taking them, so they changed her prescription. So there's a lot of stuff in here that you can find and you can sort of go through. We can look to see, did she have any immunizations? She has a flu immunization, so there's a lot of data. You can poke through these different records, and no, I don't want to save. So if I go back to the slides, we generated one patient. So sort of poke around, what do we get? We have a whole bunch of FHIR resources. By default, it outputs FHIR R4, but you can also have it output FHIR STU3 and DSTU2. These are the resources we support. So if you've played around in the FHIR spec, there's probably like, I've lost count of how many resources there are, 30, 40, 50. So we support a subset, so bundle, patient, encounter, condition, allergy intolerance, observations. That's by far the most numerous resource type. Diagnostic reports, so those are your labs. There's procedures, imaging studies, immunizations, care plans, medication requests, organizations, practitioners, claims with dollar amounts, explanation of benefits, and coverage. So there's a lot to get you going, but it's not quite everything. There's also a bunch of different settings in Synthea. As I mentioned, by default, you export FHIR and as transaction bundles. You can also change it to use you as core. You can also do STU3 or DSTU2. You can have it output the FHIR bulk data format. So there's probably been sessions that you might have heard about the bulk data format, which is basically new line delimited JSON files. So if you want that, you can generate it. There's attributes to split the records. So instead of having one longitudinal record per patient, you can have it split by the provider. So if a patient went to 3 different providers, that provider record would only have data for what they have. So if you want to show the situation of no interoperability, and then your systems are trying to do patient matching or merging, you can do that. And then you can change the whole years of history thing. If you don't want the last 10 years, but you want for some reason the whole life, you can change that to 0, which will be all, or you can change it to some particular number, 15 or 20 or whatever you want. So now that we have a patient bundle that's a transaction bundle, we can try to post that to a particular server. So I'm going to try to do that now and see if I can manage to do it. So I'm going to do a curl. I'm going to do it to the happy server. Let's see. And let me copy this. And I need to give it a header because I need to tell it what the content type is. So I'm basically issuing a curl command to the happy server. I'm telling it what file to use. Did I get that right? I think I missed I forgot to tell it to use the data binary. Boop. So let's go back there. And then I have a header that basically tells it I'm using the FHIR JSON content type. So it's going to basically just post this transaction bundle, and hopefully, there we go. So I got a response. It just outputs it, and basically it's telling me that all of these things were created. So we just created this whole patient and all their record on the happy sandbox that everyone can use. So good. So you basically just tell it to run, and then you have bundles that are ready to just post. And then the next thing I want to show you is there's a bunch of different ways you can use this. So there's a bunch of switches. You can use seed like I showed you. You can tell it particular population size. You can do gender. You can tell it a certain age range. You can filter by module, and you can also send in properties or specify different areas. So I'm just going to play around a little bit. So I can say run Synthea, and I can say seed 0. I can say population. I want to generate 5 people. So it's going to now generate 5 people. Let's see what happens. Will it do it? Interesting. It generated more than 5 people. It generated 6 people. One of them is dead. So the reason why, I get a lot of questions, why did it generate 6 when I told you to generate 5? Because presumably when you have us generate people, you want them to be alive. And so, for example, if you ask what's the population of a certain town, and someone says, well, there's 100 people that live here, presumably the 100 people that live there are living people. And so you want to have 100 living people and not a bunch of dead people in the town. So anyway, there are those people. I can also, as I mentioned, I can, well, actually, let's do that. I can specify the gender. So if I only want to generate women, I can do that. Oops. So now it's generated 5 women. I can say, if I want to specify an age range, I can say I want to do the ages 40 to 50. Now I've generated 5 women who are within that age range. There's 43, 45, 46, 45, 45. So you can filter that way. You can also specify specific models that you want to use. I'm not going to do that right now. And I can also say, I happen to generate them all in Massachusetts, and I could specify the state. You have to spell it all out. So this is a test of how good you are at spelling bizarre state names. If it's a name that has a space in it, you have to quote it. And I can also specify a particular town. Actually, I don't want to do Massachusetts. Let's do Washington, and we'll do Redmond. So now I have a bunch of 30 or 40 to 50-year-old women who are in Redmond, Washington. So, and if I list my output, what do I got here? So I got a bunch, all those patients that I've generated, and then I have something else that's sort of interesting. I have hospital files, and I have practitioner files. You can turn this off, but what it does is every time you do a run, it will, in addition to having each patient record self-contained, it has the hospital or basically all of the organizations in one file. That way you don't have to duplicate them all over the place if you don't want, and also the practitioners. So you can load those separately if you want. And this is just the timestamp of when you run it. So one of the things I can do, well, I'm actually going to, sorry for switching around. I'm actually going to remove this folder for now. So the next thing I want to do is for everyone who's participating, we've got a few minutes left. It's going to take 5 to 10 minutes to do this. If you're going to do this, the goal is try to generate something like 5 or 10,000 people, and then choose a particular state or town or city that you want. Do whatever comes to mind. I can tell you there's a few. Don't do Washington D.C. because there's a bug with that actually right now, but the District of Columbia. So run Synthea. I'm going to provide a seed because I want to. And I'm going to say 10,000. And I'm going to say, yeah, let's do Washington. But I'm not going to specify a city. Oh, well, what the heck, Seattle. Built into Synthea is not only the demographics of the whole country, but it has the list, the publicly available list of all the provider organizations in the United States that have been provided by CMS. So there's all sorts of hospitals, there's urgent care facilities, all of those things that are publicly available from CMS are in here. So these people in Seattle presumably will be going to some provider organizations that exist within the Seattle, Washington area. And it's almost generated 1,000 already, so let's just keep doing. By show of hands, is anyone else doing this, or am I the only one? Yes, thank you. Great. It's going to run for a while. This is what you came here for, to watch scrolling patients. Let's see. So the next thing that we were going to do while we were running is I have a little script here. And I was like, well, let's have everyone start posting all of their patients to one of the sandbox FHIR servers. Well, they might not be too happy with me if we did this. It might make their server go down, and it would certainly take longer than 40 minutes. So we're not going to do this step. That would just be a little crazy. But then what I'd like to do is, if you're generating data, is when you're done generating it, to zip your output FHIR folder into a file that has a name that's like this, where you have FHIR_P, which is the number of people you generated, then write the state, then write the city, have that as a zip file. Hopefully there's no collisions here, but if there is, you know, we can add a different something at the end. You can then you download the Microsoft Azure AZ copy. It doesn't install anything. It's just a pre-built executable. I downloaded it yesterday in under a minute, and it just worked. So hopefully, and I have a Mac, so it should probably just work on your machine if you have Windows or Linux. And you can delete it when you're done if you don't want it. And there's basically some instructions, AZ copy, and then you have basically like a copy command where you give a source destination. Your source is the file or the remote host file, and then your destination is either the remote host or your current the file you want to write to on your machine. And then there's also a list command where you can list the remote contents of an area. And so this area, this Synthea DevDays 2019.blob.core.windows.net/Synthea. It's long, but you can copy and paste it from the bit.ly thing. That is the hosting that Microsoft has agreed to provide, and it should be up for a few months after the conference as a read-only mode. So if people want to go later on and download all the data that we're generating here today, you can do that. Let's see. Still running. About halfway through. If I was more entertaining, I could start telling FHIR jokes. Is anyone who's actually trying to do this running into any issues? No? Good.
Just performance ones.
Just performance? Yeah.
Laptops.
Where are you trying to run?
It's just on a map. If I leave the seed off, it works just fine.
That's interesting. I don't know if maybe you can submit a bug report on GitHub issues. I've never seen that before, but I'm happy to look at it. So we're almost done.
Are there any analytics utility to see what
That's a good question. So there is a way that there's an export format. Actually, let me show you. If I go to the wiki, there is a way you can output CSV data in addition to the FHIR. So if you want a real quick way, it's like, it depends how analytically inclined you are. If you just load it into Excel and do a pivot table, you can get counts of essentially all the different types of thing it generated. Or you could also load that into a database. There's a whole data dictionary about what gets outputted. So you can sort of, that's a quick, dirty way to do it. Otherwise, you're looking at the FHIR resources. Synthea itself doesn't do any analytics for you. That's a job that we leave to you as sort of your own value add process.
How would you add more data on medication orders?
How would I add more data?
Is there a way to do that in the modules, or would that just
Yeah, so like if I wanted to add more data, like one way I could do it is in this module, I could say, all right, let's see. One thing I could do is just say, well, I'm in the encounter, and let's see, where are we? I want to do it in an encounter somewhere. Right before this encounter ends, I want to add a state, and I'm going to change the type to medication order, and I'll call it, add new medication. Call it whatever I want. It's an RX norm code. I could give it a number and say, examplitol. I can add different prescription information about dosage, duration, all that kind of stuff. So if you don't like the prescriptions it gives out, or you want to just really increase the quantity of things that get prescribed, you can modify the modules this way. You could also just change some of the probability numbers. There's a lot of numbers in here about different rates that different medications get prescribed, and you can do it that way. And then you'd click download, you click download again, and then you could copy that module to your module folder, and Synthea will pick it up and run the data. I think I'm done. Yes, 6 minutes. So it probably seemed like an eternity watching me stand up here for 6 minutes, but what it ended up doing was it generated 10,000 living people, because that's what I wanted. It also generated 1,440 dead people. So we've got about 11,440 people, or records. So in my output folder, my FHIR folder, I'm just going to zip this up. Where's my compress? Compress. And it says it's going to take about 2 minutes. And while I'm doing that, oops, I'm going to get the AZ list command ready. Oh, I want to go back to the exercises that are listed. All right, so let's see what's there. So I'm going to use this AZ copy utility to list out what's currently on there. Oh, no. There we go. Oh, cool. There's already some files there. So 2 people or 1 person posting 2 files, either way, have posted data for New Jersey, a most excellent state. Mine is still zipping. It's probably going to end up being a few gigabytes. It's starting from 9.71 gigs. So we'll see how big it is when it's done. There's a lot of compression you can get out of the JSON. Right, it's done. So I'm going to rename it. Yeah. I have, I'm not going to count the dead people, 10,000. I said Washington, and I did Seattle. Oh, I did provide it as seed, didn't I? No, I didn't record that, so that's fine. All right, good. Now, I'm going to do this AZ copy command. Let's try this. Let's just get this big, long token. Okay. AZ copy, copy. Output, FHIR 10,000. And then this giant command, which is, oops, did double quotes there, which includes basically the target, which is this Synthea DevDays 2019 blob core Windows Net Synthea place, and then there's required tokens, but the tokens will work for the next week or so, and then it's going to start uploading it. Who knows how long this will take? And then soon we'll have another data set there. So at this point, I'm going to not force you to watch that. Thank you. That's the end of my presentation. There's my contact information. You can email me. I'm also on FHIR chat quite regularly. There's a website, synthea.myer.org. If you go there, it will give you links to the synthetic mass website, which is a set of pre-generated data of 1 million synthetic patients in the state of Massachusetts, as well as a FHIR API to access those. That's basically the Google Health FHIR API. You can also, there's a link to the module builder if you want to edit or just play around or look at the different disease models we have. The Let's Build tutorial is there. And there's also an OSERA synthetic data project group. So if you're really into synthetic data and you want to start being part of the open source community that works on this project or generates data, you can always join that project group, and we'd love to have you. So thank you very much.